Hello and welcome. Today we're diving into something really cool. We're going to see how you can build an entire virtual cricket universe, pretty much from scratch. We're talking about taking raw, messy data and transforming it into a playable game that feels incredibly real. You know, it all really boils down to this one massive question. How do you actually build a virtual cricket match that feels real? I mean, one that captures all the nuance, the strategy, the pressure, the sheer unpredictability of the sport. Well, that's the exact challenge we're going to break down today.
But you know what? Let's start at the end. Before we get into the how, let's look at what was actually created. This whole project resulted in a playable game right in your computer's terminal, a super interactive web simulator, and some seriously powerful insights from thousands of simulated matches. Okay, now let's see how it was all put together.
So let's kick things off by exploring this finished creation. And I want to be clear, this isn't just some simple little program. Nope. It's an entire ecosystem built around the sport, with a bunch of different parts that all work together seamlessly. Just look at what's inside this whole universe. You've got the playable games, sure, but also the results from a staggering 10,000 simulated matches, which reveal these hidden patterns in the sport. There are data visualizations, tutorial code to learn from, even full technical reports. It's this all-in, comprehensive approach that lets you explore the game of cricket on such a deep level. So how in the world do you build something this complex? Well, like any great recipe, you start with the raw ingredients. And when it comes to simulation, the most important ingredient by far is data. This is the part where we forge that raw data into the fuel that's going to power our entire system. And we're talking about a lot of fuel. To build the foundation for this simulator, a synthetic data set of 500 T20 matches was generated. And that created, well, look at that number, over 100,000 unique ball-by-ball records. Every single delivery, a data point. But here's the thing about raw data. It's almost always messy. I mean, look here. It can have missing values like that NaN you see under the runs column, and all sorts of other little inconsistencies. You just can't build a reliable simulation on top of messy data. It has to be flawless. So through a really rigorous cleaning process, all of that messy, inconsistent data gets turned into this. Ah, beautiful. Clean, structured, and totally reliable. Every single missing value has been fixed, every entry is consistent, and this clean data set, it's so much more than just a table of numbers. It's the bedrock, it's the source of truth for every single virtual ball that will ever be bowled in our universe. Now, to make sense of all this complexity, every one of those 103,633 deliveries was simplified and classified into one of just 7 possible outcomes. You can see the breakdown right here. Singles are the most common, and threes are super rare. These 7 outcomes, they become the fundamental building blocks of our entire virtual game. Everything comes from this. All right, so our data is clean, and we know our 7 outcomes. Now it's time to build the engine that actually makes the decisions. Let's call it the simulator's digital brain. We're going to take a peek at how this thing actually thinks. This brain is pretty clever. It's actually got 2 parts that work together. On one side, you have these simple tables. They just look at history, what a bowler usually does, or how teams score in the first 6 overs. That gives you a fast, reliable baseline. But then you have the smart algorithm. This part understands the current match situation. It adjusts the odds based on real-time pressure. So if a wicket falls or the required run rate suddenly goes way up, the algorithm recalculates the chances for the very next ball. And really, it all comes down to one core concept: probability, just the chance of something happening. For every single delivery, that digital brain is calculating the percentage chance for each of our 7 outcomes. It weighs all the odds from its 2-part model, and then it makes a choice. And that process repeats over and over and over again. Okay, so we have our clean data, we have our digital brain. Now it's time for the really fun part. We can finally unleash the simulation. And we're not just going to simulate 1 match or 100. We're going to simulate thousands to see what true patterns start to emerge. 10,000. The engine simulated 10,000 full T20 matches. It's this absolutely massive scale that lets us see past the luck of any single game and really uncover the deep strategic truths of cricket that only show up over the long haul. And what did we find after 10,000 matches? Well, look at this. The results are almost perfectly balanced. The team batting first won about 49.8% of the time, and the chasing team won 49.5%. This is huge. It proves the simulation is fair, that it has no built-in bias. It's a truly level playing field. And because we know it's fair, it can give us some real strategic insights. For example, the simulations discovered that once a target gets over 200 runs, the chasing team's chance of winning just plummets to about 25%, or 1 in 4. This is the kind of concrete, actionable knowledge you can only get by simulating at this massive scale.
So let's bring it all home. We've seen the data, we've met the digital brain, and we've looked at the large-scale results. Now it's time to connect all of that back to those interactive games we saw at the very beginning and really bring this simulation to life. To make the game feel truly authentic, the simulator even thinks about where the match is being played. Different stadiums have unique modifiers. A flat pitch like Bangalore, that gives batters a little 1.12x boost. A bowler-friendly pitch like Lord's, that gives pace bowlers a 1.06x advantage. These little details add a whole other layer of realism.
And this is how it all connects back to you, the user. When you fire up the web simulator, you get to pick the teams and the venue. The simulator instantly grabs that venue's unique modifiers, it calls on the digital brain to figure out the odds for every single ball, and then it plays out the entire match, showing you the results live. Every single piece we've talked about today comes together in that one seamless, interactive experience. So we've gone on this incredible journey from raw, messy data all the way to building a digital brain and creating a stunningly realistic simulation. It really makes you think, if we can model the beautiful complexity of a sport like cricket this accurately, what else could we